Alright, using implicit differentiation, find the second derivative in terms of x and y, given the equation x, or y, or I'm sorry, 1 over y, x plus y plus 3x equals 1. Boy, I'm tired. Okay, so we have the normal differentiation here. We're just going to normally take the derivative of this, and we're going to run into the first one. You can see let's rewrite it as x plus y to the negative 1 power. Okay, and so this is going to equal, let's multiply. We're going to have to use the chain rule here. So we have negative 1 times x plus y, and this is going to be multiplied by, I'm sorry, and also subtract the exponent, so we'll to the negative 2 power. So this is going to be times the derivative of x plus y, and this is going to equal, so let's go ahead and get this back in its normal form. We have negative 1, let me separate those. So we have negative 1 over x plus y squared times, well, the derivative of x is 1 plus derivative of y is dy dx. Okay, so let's just rewrite that over here. So we have negative 1 over x plus y squared, and well, let's just move these up here too. Let's move the 1 and dy dx over here, so we can get rid of that 1 and just write 1 plus dy dx. Alright, so from here we can see the derivative of 3x is 3, so plus 3, and the derivative of a constant is 0, so we'll write 0. So now we can just do algebra to kind of get it to isolate the dy dx. There's a couple different ways you could do this. I'm just going to kind of go through it my way. Subtract the 3. That's going to give us negative 3 on that side, and we'll have 1 plus dy dx negative over x plus y squared. And so now we can multiply, let's just multiply this negative x plus y squared to both sides, and that will give us 1 plus dy dx equals, well, negative times a negative, so we'll have 3 times x plus y squared. Subtract the 1, and you have now isolated your dy dx, and you have solved for it, minus 1, and so now we have the first derivative. And basically, to get what it's asking for, we do the same thing again. So this equals the derivative of the isolated variable of the derivative. So once you've solved for the first derivative, you take the derivative, you're taking the derivative of that exact thing. And so remember what it equals here, because we're going to end up plugging that in. It's a common thing that happens. So continuing, just well, when we apply this one, in here, this is what we get. So just moving on, we're gonna apply it over. So now let's apply it over here to this, and we'll have, well, let's just move the 3. Let's move that 3 to the outside, and so we can just worry about what's on the inside here, and we have an x plus y squared. And we just did this before, so we're going to know the answer to it. It equals, pretty much the same thing. So we're gonna have 2 times x plus y, but don't forget the chain rule. So you'll have times 1 plus dy dx. And we can just throw this in over here again, what we're going to have. So let's just bring this equals sign down for now. It's kind of messy. And so don't forget the 3. And so 2 times 3, so it's just going to get multiplied back in. So 2 times 3 is 6. And just continue on. So 6 times x plus y times 1 plus, and now here's that part why we remembered to include this, or to remember this part right here. You're going to substitute it back in 1 plus 3 times x plus y squared minus 1, and this is our second derivative with respect to x of, let me zoom out a little bit. Yeah. So of 1 over x plus y plus 3x equals 1. So we have the first derivative right here. Let me go ahead and try to first derivative right here, and the second derivative right there. Not too bad.